Hello and welcome to the first in a series of new videos from Clarity Media in which we are going to look at how to create mazes. In this video we're going to look at the basic algorithm that we will use to create something that's known as a perfect maze. A perfect maze is simply a maze in which there is exactly one path from any square to any other square of the grid. So that compares to other types of mazes such as braid or weave mazes. For instance, in some mazes there may be multiple routes from one square to another. However, in this type of maze, a perfect maze, there is only one way to get from any cell to any other cell. So you can see here a very simple 4x4 maze. It's best to start with something small when you're trying to understand an algorithm or how something works, and break it down into different stages. Now, there's lots of different ways to create mazes, which probably isn't a surprise. There's a huge number of different algorithms out there, and some Googling around can reveal lots of those different types. We're going to look at what's probably one of the simplest algorithms to understand and certainly to implement, and it's called the recursive backtracker algorithm. And the way that it works is you start with a cell of your choice. It could be anywhere in the grid. In this 4x4 grid, for instance, we started with cell 1. And you have to imagine that you have a 4x4 grid in this case with all the walls marked in place. So imagine a 4x4 series of squares. And all you do is you pick your start square. So say square 1 here. And then the algorithm finds each unvisited neighbor from that square. So in the start position, every square is unvisited. So for square 1, here the unvisited neighbors would be square 2 and square 5, this square and this square. And so you would then say, okay, well, we know from square 1 we can go to either square 2 or square 5 because they're both unvisited. So let's pick one of them at random. And you can see, given the way the boundaries are, it picked square 5. So now, having started with square 1, you then move to square 5. And then from there, you repeat the process. Well, it can't go back to square 1 because that's already been visited, but it could go to this square here, or it could go to this square below it there. So again, it makes a random choice, and it picks a square. And you can see it picked this square here. And then the process simply repeats. You pick here, and then you pick here, and then it could have gone either way. Let's imagine that it went this way. So it came here and then went all the way around to the end. Then what does it do? Well, it reaches a square where there are no unvisited neighbors. When it gets here, this square has both this square and this one as visited neighbors. So this is where the recursive backtracking part comes in. So it then pops this cell off its stack, and it comes back to this square and then checks its neighbors again. They're all visited. So it comes all the way back to this square here, where it finally has another neighbor to explore. So it then connects to this square here. And then that square, and in fact all squares, have all of their neighbors connected. And so then it comes all the way back to the start and the algorithm finishes running. So there's various different ways of implementing this. You can do it recursively, as the name recursive backtracker perhaps implies. You can also just do it with a stack. So you'd start with the first square, square 1, if that's your chosen start square, and you'd put that onto the stack. Then you'd find each unvisited neighbor of the square at the front of the stack, which here, as we can see, were 2 and 5. And then you pick one at random that's unvisited, has to be unvisited neighbors. And then you make that cell the new cell at the front of the stack, and you create the link between the two. So you'd create the link between squares 1 and 5 here, and then you put square 5 at the front of the stack. Now with 5 at the front of the stack, you repeat the process. You find the unvisited neighbors, which is the square below it and the square to the right, and then you pick one at random, make the link to it, and then put that square at the front of the stack. So now square 6 here becomes the front of the stack, and you just keep on repeating the process until you find you reach a square that has all its neighbors visited, and then it simply will pop that off the end of the stack. So it will pop square 16 and 15 and 14 and 13 and all the way back until it finds a square that still has another unvisited neighbor, and then that square will be put onto the stack and this link drawn, and then it will eventually get back to the beginning. So that's a very, very simple algorithm, just using a very simple stack to create a perfect maze. So let's animate that very simple 4x4 maze being created, just to give you an idea of what the algorithm looks like in action. So what you saw there is that it went all the way around to the end, and then it went back to the square that was left in grey. So the grey squares were shown unvisited squares in the maze, and it went back there just at the end. So it's quite interesting to see how these mazes work, and by animating them, you do kind of get a sense of any quirks or features of the algorithm. So let's try making a 20 by 20 maze, and now let's animate that and see what it looks like, starting again at square one. So you can see straight away a distinctive feature of the recursive backtracking algorithm, because it's doing basically a random walk around the grid. You can see you get these very long passages, and that is a property of this algorithm, which looks nice. Some people like it, some people don't, but it does mean that you'll tend to get parts of the maze where the solver, if they're along the right route, can just kind of draw a straight line for quite a few cells without there being any decision points. So you can see how it's visited a lot of the maze, and there's some various areas that have to be filled in still. So it will now backtrack to those, and here it comes backtracking through all those regions in the order it reaches them. And there you go, that's the maze created using the recursive backtracking algorithm. Hope you found this video interesting and useful. If you did, then please do like the video and subscribe to our channel. It takes a couple of seconds, but it really does help support the channel, and also it will notify you when we release new content. Please do let us know if you have any questions or queries in the comments. We are going to record some other videos shortly in this series that will look at things like how to work out the distance between two squares in the maze, how to work out a solution path, which is obviously useful if you're going to be given this maze to someone to solve, and even how to actually visualize the maze, how to draw the maze, whether it's here or whether it's in a PDF format. Okay, thanks for watching. Bye for now.